Ever wonder why some comets seem to take breaks during their journey through space? From Halley's mysterious delays to the strange parking spots created by Jupiter's gravity, these cosmic wanderers have fascinating pit stops to share. When comets travel through our solar system, they sometimes appear to take unexpected breaks, almost like cosmic tourists stopping to enjoy the view. The main reason for this odd behavior is what scientists call gravitational interactions. Think of it like a car slowing down when going uphill. As comets move against the pull of the sun and planets, they can slow down dramatically. Jupiter, being the biggest planet, often acts like a space traffic officer, its strong gravity causing comets to slow down, speed up, or even change direction. Sometimes these comets get caught in what we call libration points, areas in space where different gravitational forces balance out, creating natural parking spots. This is similar to how a ball might settle in the middle of a curved bowl. Let's explore how these cosmic rest stops actually work. When a comet travels through space, it's like a car navigating through hills and valleys created by gravity. These valleys, which scientists call Lagrange points, are special places where gravitational forces balance perfectly. Imagine placing a marble on a stretched sheet with different weights on it. The marble would naturally roll into certain spots and stay there. That's exactly what happens to comets. There are 5 main Lagrange points in the Earth-Sun system alone, each acting like a natural parking space. Some comets get temporarily trapped in these spots, while others might slow down significantly as they pass through. These areas are so stable that even NASA uses them as parking spots for some space telescopes. Let's look at some famous comets that took unexpected breaks during their space travels. Halley's Comet, probably the most well-known cosmic wanderer, sometimes shows up later than expected. In 1682, astronomers noticed it was running about 2 years behind schedule. Another interesting case is Comet Shoemaker-Levy 9, which got caught in Jupiter's gravity field and broke into pieces. It was like the comet pulled into a rest stop but crashed into the parking lot. The Churyumov-Gerasimenko comet is another fascinating example. It actually changed its path after getting too close to Jupiter in 1959, making its visits to the inner solar system more frequent. These cosmic slowdowns helped scientists better understand how gravity affects objects in space. Let's zoom in on Jupiter, the master architect of cosmic parking spots. The giant planet's massive gravity creates what astronomers call gravitational keyholes, special zones in space that can trap or redirect passing comets. When a comet gets close to Jupiter, it's like a small boat caught in a whirlpool. The planet's gravity can pull comets into stable orbits around it, or even fling them into new paths around the Sun. The really cool part is that Jupiter has several of these natural parking spots called Trojan points, where thousands of asteroids have been camping out for millions of years. These spots are so stable because Jupiter's gravity perfectly balances with the Sun's pull, creating cosmic sweet spots where objects can hang out for extended periods. Let's talk about these amazing sweet spots in space called Lagrange points. They're like nature's perfect parking lots in the cosmos. Named after mathematician Joseph Lagrange, these points are where opposing gravitational forces create balanced zones. Imagine a beach ball floating perfectly still in a pool. That's similar to how objects behave at these points. There are 5 main Lagrange points in the Earth-Sun system, labeled L1 through L5. L1, sitting between Earth and the Sun, is where we park solar-watching satellites. L2, on Earth's far side, hosts the James Webb Space Telescope. These points are so useful that space agencies use them as fuel-saving spots for spacecraft, like cosmic gas stations where vehicles can rest without using much energy. Let's explore one of space's most interesting mysteries, objects that can't decide if they're asteroids or comets. These cosmic hybrids start as normal comets, but get stuck in the inner solar system, losing their icy tails over time. Take asteroid 2015 TB145. Nicknamed the Death Comet. It was once a bright comet but got trapped closer to the Sun, where its ice slowly disappeared. Now it looks like a dark asteroid but still follows a comet-like path. The asteroid belt between Mars and Jupiter is full of these former comets that lost their sparkle. Scientists found that about 8% of near-Earth asteroids are actually these retired comets in disguise, giving us clues about how our solar system formed. Let's explore how the Sun acts like a cosmic barista, serving up streams of energy that can dramatically change how comets behave. When comets get closer to the Sun, they encounter something called the solar wind, a constant flow of tiny particles shooting out from the Sun's surface at incredible speeds. These particles hit the comet like a strong breeze, pushing against its dust and gas tail. The closer a comet gets to the Sun, the stronger this effect becomes. Sometimes this solar wind is so powerful it can actually slow down a comet's movement, like driving a car into a strong headwind. The Sun's heat also makes the comet's ice turn directly into gas, creating those beautiful tails we see from Earth. This process can make comets look like they're taking a break when they're actually just fighting against the Sun's influence. Sometimes space gets a bit crowded, especially when multiple comets decide to take the same cosmic highway. Back in 1770, astronomers watched in amazement as Lexell's comet passed incredibly close to Earth, only to have Jupiter completely change its path later. It's like a cosmic game of bumper cars. When comets cross paths, they don't usually crash. Space is still pretty empty, but they can affect each other's orbits through gravity. The asteroid belt is like a busy intersection where comets often slow down and weave through the space rocks. In 1994, scientists got a front-row seat to an amazing show when the pieces of Comet Shoemaker-Levy 9 lined up like cars at a traffic light before crashing into Jupiter. Let's dive into one of space's most fascinating mysteries: sleeping comets. These cosmic snowballs sometimes go into a state that's like a deep winter nap. When comets travel far from the Sun, their surface gets covered with a dark, crusty layer that acts like a blanket, hiding the ice underneath. This dark coating is made of dust and complex carbon compounds that build up over time. The comet becomes so quiet and dark that astronomers might mistake it for an asteroid. The most famous sleeping beauty is Comet 107P Wilson-Harrington, which looked like an ordinary asteroid for 70 years until it suddenly woke up and sprouted a tail in 1949. Scientists estimate that there could be hundreds of these hibernating comets in our solar system, just waiting for the right conditions to wake up and shine again. Modern technology is making it easier than ever to predict where comets might take their next cosmic coffee break. Using powerful computers and detailed maps of gravitational forces in our solar system, astronomers can now forecast a comet's path decades into the future. They look for places where comets might get caught in Jupiter's gravity or drift into those natural parking spots we call Lagrange points. Some exciting predictions suggest that Comet 55P Tempel-Tuttle might slow down significantly during its 2031 visit, giving us a longer show of the Leonid meteor shower. Scientists are also keeping an eye on several comets that are heading toward Jupiter's orbit, where they might get caught in the giant planet's gravitational dance. Thanks for joining us on this fascinating journey through space. We've only scratched the surface of these cosmic mysteries. If you enjoyed learning about cometary pit stops, hit that like button and subscribe for more space adventures. Share with your fellow stargazers.